Problem number 6 is a polar graphing problem. It gives you two curves, r1 squared equals 2 sine of 2 theta, and r2 equals 1. And it wants you to find the area inside both of those curves in the first quadrant. So let's go ahead and let's see if we can get a graph of this overall shape so that way we can identify exactly where our area is going to be. So the first thing I'm going to do is I'm going to set these two equal to one another. 1 equals 2 sine of 2 theta. So again, this is r squared, but if I go ahead and just square the other radius, I just end up getting 1 anyway. So this tells me that sine 2 theta is equal to 1/2. Sine is 1/2 in the first and second quadrant, at least positive 1/2. So 2 theta is equal to pi over 6 and 5 pi over 6. So if I get my overall definition for theta, I end up getting pi over 12 and 5 pi over 12. So these are my points of intersection. Now, the next thing I need to do is I just need to figure out what this graph is going to look like in general. So this one's pretty easy to graph, so I'll actually just go ahead and write that one out just to save myself a little bit of time. So this is just going to be a circle with a radius of 1. So I'll call 1 right here. I'll try to draw as symmetric as possible. Not really that symmetric. Probably do a little bit better than that. So if I go ahead and try to connect it there, that's a little better. Okay, we'll call that, this is R2. Now I need to figure what R1 squared is going to look like. So again, I know that when it's squared, it's going to be like an infinity sign. So I just need to figure out where that infinity sign is going to be oriented. Now, if I go ahead and set it equal to 0, I can figure out where it's going to return to 0. So that should help a little bit. So if I set this equal to 0, I end up just getting sine 2 theta is equal to 0. That tells me that 2 theta should be equal to 0, pi, and 2 pi. And if I go ahead and divide out that 2, I end up with 0, pi over 2, and pi. So these are my zeros for R1. So now I can go ahead and I'll make a little chart just to graph it. Again, graphing the infinity signs doesn't really require a lot of points. So I'm going to start with 0. I'm going to write out pi over 2. And I'm going to pick a non-zero point in between it. I'll pick pi over 4. Because I know that if I plug in pi over 4 here, it'll give me 2 times pi over 4. That's pi over 2, so I know I'll get a guaranteed value for sine there. But I know that the other two values around it are just going to be zeros. So if I go ahead, plug in pi over 4, I end up with sine of pi over 2. Sine of pi over 2 is 1. So I end up with r1 squared is equal to 2. Remember, when you're graphing these infinity signs, there's a couple different ways you can do it. The way I usually prefer is by taking the square root of this, I end up with plus or minus square root of 2. So what I'm going to do is I'm actually going to graph it at the same time. So I know that my starting point in this case is going to be 0. I know at pi over 4, I'm going to extend out to a radius of square root of 2, which should be greater than the radius of my circle, because I know that the radius of my circle is only 1. And I know that on the other side, I'm also going to extend out to the same direction. That's my point. That's my point. If I come back down like this, I close my infinity sign at pi over 2. Same thing down here. We share the same location. So now I have my overall shape. I know that these will be my points of intersection. Pi over 12. 5 pi over 12. So now I think I'm ready to go ahead and find my shape. So it does say that I want to find the area inside both curves in the first quadrant. So I'm isolating myself just to this first quadrant right here. I want to find the area inside of both curves. So I look for where the curves overlap each other, and it looks like it's right here. Great. So now I just need to figure out how to define this area. So I do know that my overall equation for area is going to be 1/2 integral r squared d theta. So I just need to figure out how I'm going to define my radius in this case. Now I need to be careful, because if I do want to find the total area, I need to look at this kind of carefully. So if I want to find the entire first quadrant, nothing is cut off in here. So I do know that my integral is going to have to at least extend from 0 to pi over 2. And again, that's just from the fact that it says it's only in the first quadrant. If it says that it's limited to 2 quadrants, I do need at least that amount of area. Because if I'm tracing the entire first quadrant, it should go from 0 to pi over 2. So now that I know this, I just need to figure out how I can break it up accordingly to get that area. So let's look, starting from 0, if I extend out my radius, I actually end up hitting this R1 squared curve. And I end up hitting it all the way until I get to my first intersection point, which is pi over 12. So I know in this case, I'm just going to clear some room here, I know that the area, the total area, at least initially, will be from 0 to pi over 12. And to get that area right here, to get this little bit of area in here, I'm going to have to integrate R1 squared. So that's my first bit of area. Now, from this intersection point, pi over 12, to 5 pi over 12, the other intersection point, if I look at where my radius is tracing, it's actually tracing along the curve of the circle. So what that tells me is that from pi over 12 to 5 pi over 12, I have R2 squared d theta. And now, to cap it all off, I need to go from 5 pi over 12 to my ending point of pi over 2. So the way I do that is, again, I look where I'm tracing, and I go back to tracing the edge of this infinity sign. So because my radius is only touching that point, I end up with plus 1/2 integral 5 pi over 12 to pi over 2 R1 squared d theta. Great. And now, in the essence of simplification, I can say that 5 pi over 12 to pi over 2 is the same distance as 0 to pi over 12. So in reality, these integrals are the same area. So what I can actually do is I can treat this as just another multiple of this. So what I'm going to do is I'm just going to rewrite my final area equation as 0 to pi over 12 R1 squared d theta. And if you'll notice, the 1/2 is gone because this plus this will give me both of these little areas inside of here. And adding those together, because they are symmetrical, this can go away and just be combined into this. So now I don't have a 1/2 in front of there anymore. It's just 0 to pi over 12 R1 squared d theta. Plus the integral of 1/2, so there's still a 1/2 on this one, pi over 12 to 5 pi over 12 R2 squared d theta. So I now have these two integrals combined to form this, and I now just have this integral rewritten. So this should be my final answer. And looking at my final answers, I end up getting letter E as the correct response.
The Teaching Center, UF's Learning Resource Center.